Today I'm going to talk to you about roots. In particular, two types of roots, one called square roots and the other one called cube roots. So let's start off with the first. Okay, so square roots. In symbols, it means some number squared equals y. If we have this relationship, it means that x is a square root of y. So let's take a look what that means in numbers. So we have 3 squared equals 9. We know that's true. So because of this relationship, we know that 3 is a square root of 9. Now there's a symbol that goes along with this. This symbol or sign almost looks like a division, but it has this little extra lip right here, and it's called a radical sign or a square root symbol. Okay, so in this example, we have the radical or the square root symbol over 25. They want us to find the square root of 25. So we think of what factors, or 25 can be written as 5 squared, thinking of the definition we just had of square roots. So 5 squared equals 25, therefore the square root of 25 is 5. And in reality, yeah, we'll just stop it there. Right there is 5. Okay, in this example, they're asking us to find the positive and the negative square root of 36. And again, we think of 36 as being 6 squared. So the square root of 36 is 6. And since we're trying to find the positive and the negative of it, we have a positive and negative 6 as our answer. We can even find square roots of fractions as long as the fractions are the perfect square form, like 4 right here. We know 4, the square 4 can be 2 squared, and 25 once again is 5 squared. So we can find the negative square root of this to be 2 over 5. So we only found the negative since it had the negative sign on at the front. Now in this problem we have an equation, t squared equals 144, and they want us to solve for t, meaning we want to get t by itself, but it's being squared. Well, being squared and the square root are inverses each other, so we are going to apply the square root to the t squared on the left. Whatever we do to the left, we have to do to the right, thus giving us this equation, square root of t squared equals 144. Now, anytime you take the square root of two sides, we're going to find both the positive and the negative square root. So we're going to end up with t on the left, because these are inverses, so they cancel, the square root and the square cancel each other out, leaving us with t. And over here, the square root of 144, that's a perfect square. That's 12 times 12. This ends up being a plus or minus 12. Now you may ask, why do we have a positive and a negative? Well, if you think about it, if we were to plug a positive 12 into our original equation, 12 times 12 is 144. As well as if I plugged in or substituted negative 12 in here, negative 12 times negative 12 is also 144. So therefore, the two answers for t is a plus and minus 12, or a positive and a negative 12. Once again, we are faced with solving an equation with the square, and so we want to isolate our m. So we're going to use the inverse operation of squaring, which is the square root. So we're going to take the square root of m squared, and we're going to take the square root of negative 16. Now here we end up with m on the left, but there is no way we can multiply a factor times itself to get a negative 16, because we know a negative times a negative is a positive. So we can't get two equal factors underneath here. So therefore there is no solution. We cannot take the square root of negative numbers, no matter if they look like perfect squares or not. There is actually no, to be real, it should be no real solutions. And we'll go deeper in that as you progress in your math careers. But right now, no solution is good enough. But in reality, it's no real solution. Okay, so the second type of root we are going to cover is cube roots. And again, we have our symbolic definition where we have some number raised to the third power equals y, which leads us to the fact that that number, x, is the cube root of y. And cube root also has its own symbol. It looks just like the square root except for it has a little floaty 3 out here. This is the cube root right here, the cube root radical. Okay, so say we want to find the cube root of 8. Well, we need to find a factor that has a base that's raised to the third power, and that factor would be 2, because 2 times 2 times 2 is equal to 8. Therefore, we get the cube root of 2 cubed, which is 2, because we have a cube root and a cube, which are inverses of each other, leaving us with just 2. Unlike the square root, the cube root, you are able to find a cube root of a negative number. For instance, we can have the cube root of negative 27 be, if I multiplied this out, this is negative 3 times negative 3 times negative 3. Or in other words, we have the cube root of negative 3 cubed. So we end up with negative 3 as our cube root of negative 27, because a negative times a negative gives us a negative right there. So cube roots, we're able to find the answer, or the cube root of a negative number, but square roots, we cannot find the square root of a negative number. Okay, one last tip I want to give you when dealing with roots is either having a list of perfect squared numbers and perfect cubes handy, either write them out or have them available, have them memorized. It'll make it easier for you. If not, you have to prime factorize and try to find any repeated factors to find the square root and cube roots of these types of problems. So these are problems when we're dealing with perfect squares and perfect cubes. All right, well, good luck.